Welcome back to this series on basics of pybamm. In this video, we'll look at usage of matplotlib to create custom plots. First, we'll take a look at how to extract the output parameters and then what their exact names are. For example, voltage, current, SOC, capacity, and so on. And then once we know the exact strings to call out, how we can use that to create custom XY plots where X is not just time, but it could be capacity, SOC, and so on. And then lastly, we'll take a look at how to combine different plots together to define different axes and color coding. So let's get started. To begin with, we will install matplotlib if not installed already. So we'll do pip install matplotlib. For me, it's already installed. So it says requirement already satisfied. For first time installation, it might take time. Now, next step, I'll import pybamm, which was already installed in the last video. Then we'll define the dfn model, pybamm.lithium-ion.dfn. There are different variants, dfn, spm, spme, and so on. We covered it briefly in the last video. So if you're not able to follow how to set up dfn, experiment, simulation, and solution, watch the previous one. I'll cover it quickly in this one. Then we'll set up experiment. And experiment for us is simply defining a discharge. So we'll use the string discharge at 1C until 2.5 volts. If it's a LFP, we can go for 2 volts. It's probably an NCM or NCA in this case. So we are going till 2.5. Then once we've defined the experiment, next step is to define simulation, which is pybamm.Simulation. Then enter model dfn, comma, experiment equals to exp. Then finally define solution sim.solve. And there we go. So this is how you define a simple experiment of discharging at 1C until 2.5 volts by using dfn and its default parameter values and solving it for just one scenario. Now, if we just quickly looking back at what the default plotting options are. So when we do solve.plot, it does give out some predefined plots which are not customizable. X and Y are predefined. And we'll see these 8 plots which are good for initial overview, which consist of some negative, positive, and electrolyte plots along with current and voltage. But this is not what we would like to do in this video. We'll like to instead plot the outputs of our interest explicitly, and for that let's understand what the parameter what are the parameters or outputs available within the dfn model. So for that you just need to do dfn.variables.keys. So this will basically give out all the outputs that are present within this the dfn solution. It's a huge list and it's impossible to go through it manually. So we need a loop. For that, let's do for key in dfn variables.keys if let's say we want to only plot time. So for if time is present in key, only then we would like to print the key. When we do this, the entire list is now trimmed down to only outputs which has time in the same case formatting, so it's sensitive to how we define t. So if I remove it, it will give out other outputs. So be careful with that. You can do some logic, additional logic to make it lowercase and so on, but let's not go into that. For now, let's understand how to find out the keys which we saw here, and then now let's see how we can use it. So now we can define a variable time where we can store this output from the solution. So solve, then we open up square brackets, copy the string, and then do solve.entries. So this way we have now extracted the time output or time variable from the solution which we solved here, and got all the entries and then stored it in the time variable. Same way we can do for voltage. The voltage can be found with this variable. So let me just list down what we need. So we need voltage, we need current, capacity, SOC. Okay. For voltage, we have this expression. I'll update it here. For current, we have this one. For capacity, we have discharge capacity. And then for SOC, let's see what do we have. So there's nothing by the name SOC. Let's try SOC. Nothing here. Sometimes it's also written as S small OC. So nothing here as well. So the problem is there's nothing with the name SOC, neither with the name state of charge. Try it out with the capital S as well. So there's no predefined state of charge variable, and that's a limitation. Let me know in the comments if you know of any, and if I missed the right naming convention. But as far as I know, there's no direct output for SOC, and this is something we need to derive. And it's fairly straightforward with the help of capacity and nominal capacity. So SOC can be written as 1 minus capacity by nominal capacity. Now we'll come back to how to derive Q, but for now let's comment it out and go to the next step. So let's find out Q now. For that, again, we just need to do dfn dot parameter or other default parameter values, and it will list down all the parameters. If you click on scrollable elements, you'll find something by the name nominal cell capacity. Now its value is 0.68. We can copy this directly, but to keep it generic in case later we let's say change the parameter set, it's always a good practice to use the dictionary variable name instead of the value. So we can just go back and define Q now. So Q is equals to dfn dot default parameter value and then nominal capacity. So we can now print Q as well. It's 0.68. It's rightly extracting it, and finally we can do SOC equals to 1 minus capacity by Q. Since we are starting with fully charged cell, and that is something we could actually define here. Initial SOC equals to 1, and let's solve everything down so we have the right set of values. So now we have everything we need: time, voltage, current, capacity, and SOC. Let's see how we can plot it out. So for that, we'll now import matplotlib.pyplot as plt, and then do plt.plot time comma voltage. So if you notice, it requires array like, which is just variable. So we just need to pass it time and voltage, for example. So that's how you can simply create a custom plot. Now, I, there are no labels out here. So for that, you can do plt.xlabel or ylabel, and then define a string. So x is time and y is voltage. So now you can see we have the right labels. Similarly, you can also extract current and change the name. Maybe I'll create a separate one quickly just to have both of them here. This is voltage, this is current, and that's how you can simply plot different quantities. You can also change the x values from time to capacity. So now x no longer is time but capacity, or you can do SOC as well. So now it's versus SOC. Uh, let's rerun this once again. Okay, there's something wrong here. Maybe let's remove this for now. Okay, so we are able to discharge it and get the discharge, basically get the SOC versus voltage plot. Similarly, we could also do capacity versus voltage and change this to, say, capacity. So now we have capacity versus voltage output. Now, what if we want to combine these two together and have the same x, which is time? So for that, we can simply use the subplots option within the matplotlib library. So the syntax goes like this. Define a figure and the first axis, which is ax1, and say plt.subplots. Then firstly, we'll define the voltage plot. So ax1 dot plot, then time comma voltage. Now there's a third option to define color as well, which would be set to, so you can set the color to tab colon blue. So this way the plot line will come as a blue color. Now we would also like to set xlabel. So the syntax is x1 dot set xlabel, and then we can call it time in second. Next up is ax1 dot set ylabel, and then name it voltage in volts. It's probably a good idea to give a color to y label as well. So let's do that. Color equals to tab blue, and then finally the access labels or values, the ones you see here, 0.65, 0.66. Let's say we want to even color these out. So we will call pick param, and then axis is equals to y. We would like to keep x same as black for now. So we'll call out y. Then label color instead of color. If you use color, then it will just update these ticks. If you want to update this one instead, then go for label color and then set it to tab blue. So let's see how the plot looks like now before we add further. So plot plt.grid and plt.show. So this way you can see x is black, the plot is blue, y labels are blue, and y values are blue. This is exactly what we wanted, and we also see grid now. Next up, we should now also add ax2. So ax2 will share the same x. So we will say ax2 equals to ax1 dot twin x. So they will share the same x. ax2 dot, we don't have to define xlabel anymore because it's already defined up here and it's a twin of that. Although we need to define the y label. So firstly, let's define the plot itself, which is time comma current comma color equals to tab red ax2 dot set y label as current in ampere, color equals to tab red, and finally ax2 tick params set as red. Here we go. So with this, now you can see we can plot multiple parameters on the same plot and compare them together. So hope this was useful and see you in the next one.